DEVCLUB. They provide this file that contains within it global elevation for every arc minute, right? So this is in a format called the netcdf, and it's about 466 megabytes of this netcdf file. Netcdf file is a rather interesting beast. So let's take a look at inside it. Just a second. So I'm not going to type all of this out because it just saves time and typos. But using this, we use this library called netcdf4, and let's also use the standard tools of the trade, which are NumPy and SciPy. These are efficient implementations of scientific computing and for Python. So these are implemented in C and Fortran to make it really fast to process large amounts of data. So, okay, but anyway, let's open this. Let's open this data set in a read-only mode. And then let's look inside. A netcdf file inside it has things called variables, right? All right. So we can see that in this, can everybody see this actually? Okay, good. In this file, we have variables x range, y range, z range, spacing, dimension, and z. So we are interested in the z variable because this is actually where the elevation is stored. So let's take a look at how this is stored here. So shape. This tells us that this is a one-dimensional variable with 233 million entries. Right. This is a good example of scientists producing data files, because while this is actually a two-dimensional array of elevation data, they choose to store it in one-dimensional array for some reason. And then, of course, they luckily they include this another variable which is called dimension. Which, nicely enough, gives us the actual dimensions of the data, which is 21,601 by 10,801. So let's try and correct this, what these guys have done, and let's convert this into actual two-dimensional array. So for this we use NumPy. NumPy is something that actually very good. So what we do here is we take the z variable, take all the values from the z variable, which are this 233 million of them, and we tell NumPy to reshape this into the dimensions that the creators of this file luckily provided. Okay, now it's done. So that was processing 460 megabytes of elevation data in about 2 seconds on my laptop, which isn't that fast actually. So already looking at this, we know that this data can be processed quite fast. And of course, this is using the simplest technologies. There's a couple of other libraries, for example, GDAL, which is a library that can do all kinds of interesting projection stuff and can automatically parallelize this. You can apply again, cluster computing solutions to do this on extremely large data sets quite quickly. Right. But still, this great data, now we can verify that this has the correct shape. So, but this is too large to actually show on the screen. There's a very large amount of data points. And if we want to do some simple visualization, let's scale it down. Right. So let's say we want a grid that's actually 500 items wide. So let's first calculate the ratio that we need to scale down by. So let's divide 500 by the dimension, which gives us a downscale ratio of 0.02. And of course, luckily, we also have a tool in SciPy that can do this downscaling. Now SciPy is somewhat similar to NumPy in the sense that it's an efficient implementation of several scientific algorithms, and it's quite large. What we use here is we use an interpolation tool to downscale the data. Oh, it's done already. Thought I would have to talk longer to wait until it's done, but oh well. Now, what should we use for actually showing this data? Well, let's take the simplest thing. I mean, I know we could use Unity, but we choose not to. We choose to do this in a regular web browser. So for that, what the simplest thing is to just save this as a JavaScript file. This is not the prettiest solution I know, but for quick and dirty displays, then let's just do it like that. So write this into, right. Right, so now what we have this file called data.js. Let's take a look at that. Yes, it takes some time to exit Python. So this is basically now a file that defines a JavaScript variable called elevation that's two-dimensional. It has a large number of elevation measurements in it. So how to then show this to the user? Well, of course, these days everything is in 3D. So let's do 3D. For this, there's a nice technology called WebGL. And that we're going to use. And this works in actually a surprisingly large amount of modern browsers. Right, this code I'm not going to write online because it's slightly too long for that. So what I have this prepared here. I'll just walk you through it, what we do here. Wow. That's all right. Okay. Anyway, so we have regular HTML file, but there is some boilerplate in the beginning. So we're not going to write the WebGL code, all of it ourselves. We're going to use 3.js, which is a small 3D library for WebGL, because while writing the shaders is certainly fun. Let's just not do this right now. And also here we include the first person controls, which are controllers that let you fly around in this. And then we also include this data.js that we just generated that contains the elevation data for the world. So here we set up some stuff, and then using this 3.js, the simplest way to do this is create first a plane that is straight, and then distort this plane based on this elevation data that we have just created. Because this is actually the very simplest thing to do. There is no projection. We don't transform the coordinates anyway. We just put them on a rectangle on the screen.
So it's a height map?
Sort of, yes, basically. That's a height map. So, but, and we downscale here by 1500 because the coordinates that we are using are scaled down a little bit because the height is in actual meters and we are using 3D coordinates. So let's scale it down a little bit. It's 1500 here is rather arbitrary, and we can certainly change that to make the mountains higher and the seas lower. So another thing that we need to do is for each, now we have the triangles with correct elevations, right? Another thing we need to do is we need to color these. So now let's try to keep this very simple and do the simplest possible solution here, which is again just color them based on. This is not good. Color them based on the elevation. So we have a small function that gets a color from elevation, gets an elevation as parameter. And so what we do is Well, approximately the height difference of the Earth is from minus 10,000 to plus 9,000. So let's just make it grayscale, divide the elevation by the height difference, and use that as a color. It's very simple and should show the color gets whiter as we go higher and the darker as we go lower. Right. And then the rest of it is basically just also boilerplate. We create the material, a mesh, insert the light in the scene, and then tell 3.js to render this inside of a div. So, but then let's run this and take a look what actually happens when we run this. All right. Nope. Okay. This manually. No, still no.
But you actually could make a shader which calculates the color.
Yeah, absolutely. But actually, what 3.js does is that it creates the shaders itself. So you just define the geometry and the colors and stuff, and then, well, okay, there we go. So this is basically a very simple thing where we can fly around the Earth and look. And as the data, we downscale the data, so it's not very precise, of course, but yeah, I think for something that you could do in about 20 minutes it's not bad, right? But let's not stop here. And whoa, where is it going? Oh my God!
Crash.
Crash. So yeah, this was as I said, the simplest possible thing that I could come up with actually involving 3D. So after a little bit of tuning this, we can achieve results, for example, called like this, which involves a palette and some other interesting things. It looks a little bit better. If you want to talk about how this is different from the previous one, then we can talk after the presentation, or if everybody's interested, I can explain it here as well. Right. So
is the data which you gathered, is it like free for everyone?
Yeah, absolutely. It's GEPCO is the GEPCO data is free, and there are actually several other data sets as well that have this elevation data. There's eTopo and a bunch of other stuff as well. Right. So this is basically what I wanted to show you. Oh, anybody have any questions? You first.
Well, do I understand correctly that your business is to visualize the data publicly available? The value you create is the visualization of this data.
Well, I think Andre would be better equipped to answer this.
So imagine you have all the data about the ocean. So what useful things can you do with the data? Visualize. Sell the product that visualizes. Sure, that's the first. So we offer the software that we have created to companies who have wide range of different organizations collecting data for them, and then make it really efficient. Shorten the time 5 times it takes to make insight. So if you need to make a decision in a boardroom or a meeting, you open up Marinexplore. With visuals, you quickly explore and see the details anywhere in the ocean where your business is. So yes, we can sell the visualization. Now the second piece, if you think about the hardware in the ocean, how much does a day with a ship cost? Or how much effort goes into developing a buoy or an array of buoys? This involves considerable amounts of money. So to make sure and makes sense that these investments are utilized to the best, we enable those companies to share the data they have collected with others. If you think about the earth and the oceans, some processes take a bit of time, but influence tremendous amount of people, since 40% of us lives close to the sea, as we in Tallinn. So you want to have all the data about the location to make the best decision. And to make the best decisions, you need to have those data integrated, blended together from models and sensors. So we offer the companies who collect the data means to resell the data. And Chris, who is sitting behind you, along with Iila, they have developed the data market where you can purchase data sets, the bathymetric high-resolution data sets, where you can go up to a centimeter, know what's going on, and or you can buy acoustic data sets, because if you want to say, for example, whales from colliding with ships, then you need to measure the sounds of the whales, and based on that decide where to route the ship. So for that you need to purchase acoustic data. So that's two different businesses we have. One, selling software. Second, allowing companies to sell their data for higher impact.
So you're participating in this process as a marketplace?
Yes, we are going to launch data marketplace soon. It's not yet public, but what you can see is the data and capabilities we have in the system.
Okay, thank you.
Yeah, you had that first.
I heard there is a big problem right now that a lot of garbage is floating in the oceans, like huge piles, almost like islands. Do you have that data on those?
But data about this garbage, it's not available from Marinexplore.org. But what we actually did, we had some community members that were active in this, trying to track down where it is, and actually one of our guys helped them with our ocean current data. For example, there was a initiative called Clean Up the Mediterranean. And so what we did is we gave them our data about the currents, and using these you can actually tell where it collects, because in the ocean there's certain flows where the warmer water goes up and colder goes down, so you get vortices, and the trash collects at the edges of these vortices. And using this data, they were actually able to predict where this would be. So that was quite cool. Who was next? Okay, here. Sorry.
About data processing. How are you showing visualizing offline data, or you gathering something from real time? Or what's the delay between?
The delay, well, the delay of course very much depends on the device, and actually most of these ocean-based devices, since the data communications is rather expensive in these remote places, what they do is they store it internally for a little bit, and then they send it in chunks. Right? We have worked with a company called Liquid Robotics, who has these powered gliders to get the data off of those faster. We have actually done a couple of demos with them, but currently the data that is available public, this comes at I think the most often updated ones are the HF radar, which are about half an hour right now. But for private data sets, there is more capability.
Okay, and do you have any plans to do actual real-time kind of visualization of what's going on?
All of this data that is coming into our system is available to the visualization right after it's processed. So that it slightly depends on. This is a very hard question to answer, because it very much depends on the nature of the data. So if you have two-dimensional ADCP data, then you have to transfer all of it before you can visualize it. So it's we can talk about it later in more detail. Yes.
So obviously the data, the value of data is actually in predictions. So are are you planning to build it into a business model of kind of predicting in some sort of, for a shipping company to predict actually something happening, some events?
The market for analytics products is very specialized, very compartmentalized, and actually quite crowded. New companies are coming up all the time. We are not in this sector right now. What we are doing is we are providing the data, access to the data, ability to query the data. So the analytics tools, a lot of these are, by the way, in-house developed, for very specialized, very narrow. So we don't do this right now. Yeah.
How do you manage the politics of taking in all this big data from either governments or other groups, and then sort of gather it all up, get everybody to cooperate, and allow you to then either analyze it, resell it, repackage it? How does that?
Andre can again talk more about the details, but what I can say is that of course, we have to deal with it. But this data is from research organizations and universities. They have to make it available for public anyway. Okay, so this is what we gather publicly. Of course, again, for private data sets, it's different. But yeah, if you want to talk more about this, then you can talk with Andre a little bit later. In the back, there was before.
What kind of infrastructure are you running on? So when I go to this service online and make a query, is it going to a cloud somewhere, to a cluster of the database cluster? You have the PostgreSQL logo up there.
Yeah.
Are you using it for all the data? And how big is data set in general? All of the data.
I can't answer that question because we do have some private data sets as well. But we run on AWS, Amazon Web Services. And yes, we do have data in Postgres. And as I said, we also use Vertica for, let's say, more online analytical queries, which is what Vertica is for. Basically, it's a compressed, the tagline is that they're a compressed columnar data store for all your analytics needs. Yeah.
What's the ballpark figure, like terabytes, gigabytes, exabytes?
I wish I could say exabytes, but no. Right now, it's still in the terabyte range. But yeah, it's growing pretty fast.
How many sensors do you plan to cover? Let's say, if you said 2 million are out there, probably gathering information and won't be active, and you have 40,000, right?
Yeah.
How much do you need to actually be able to say that, okay, we've covered like 80% of the needs or something?
Yeah, from those 2 million, most are private actually. So we can't gather data from all of them. I'm not sure how many public ones there are. But certainly we are not have data from all of them. We do have an ongoing effort to gather this data continuously but you have to negotiate agreements with these organizations and integrate new data sources, and it takes time. I mean, of course, our end goal is to have it all, but it's a process.
Where you took the idea to start this business development?
Andreas started it, so he can explain it.
Actually, the story goes back 4 years. My co-founders, Rainer and Kalle, they built a buoy, which sits in the Baltic Sea. And this buoy in itself was already quite an invention. It was lighter than anything else. It was excellent design work. And when they discovered that for the guys owning the buoy, it took 3 months to make sense of what they had gathered. They figured there is an opportunity, and when we met and I was working with milliseconds for Skype data, then it was kind of obvious that there is an opportunity of technology transfer. Here we are now. So that's the story. But yes, Rainer and Kalle were the original inventors, and they worked with Raido, who's sitting back there, when they discovered this idea that, okay, why don't we create Google for oceans? So if you go to Marinexplore.com, you can browse the oceans. You can search for anything you desire.
Except private data.
which is available for a fee, of course.
What OS means in the name?
Well, because we want it all.
Not operating system.
No, it doesn't mean operating system, but what does the OS mean in iOS? Right? Does it mean operating system? No.
Operating system.
Yeah, but of course it's just a word, right? Nobody uses it as in that sense.
For operating ocean data.
Yeah. So you can create your own definition. Yeah, yes.
So what kind of data formats are we talking about here? 'Cause if I think of like nearshore solar stuff, I can rattle off about 10 different formats off the top of my head. So.
Yeah, and for our customers, we have never received data in the same format from two different customers. So it's definitely, but this is what we do. This is what our ETL system is for, to handle this data in different formats and be able to process it in a unified manner and index it.
Okay,
So
how do you achieve that? Like if I think about again nearshore solar stuff, then like small private company, I know it's been like a 3-year journey just to fit five different formats into something that they can make sense of. So how do you guys do it in a way that we can run with it faster?
I'm not going to tell you the exact technology right now, I'm afraid. But yeah, we do have some solutions available for this. Again, we can talk later privately about this in more detail. Yes?
I'm interested, like, how big is your engineering team? You said like 2 years it took for like this to be, it's like awfully short time.
Thank you. Our engineering team right now consists of 1, 2, 3, 4, 5 people.
Well,
Right.
altogether it took, let's say, about 12 people 2 years to get where we are. And we've done it in a way where we build upon what others do. So in our community, we have 7,000 professionals. And through them, we have found the best choices fast. And we continue to work with different companies, technology companies. So these days, if you make the smart decisions, it's possible to deliver fast with a small team.
And you saw what we could do in 10 lines of Python code. So it's
10 line of pre-made.
yeah, but no, seriously, the Python part took me about 20 minutes to write and test. So it really in some areas, if you do a very specific thing, then and you know the tools, then it can be quite fast. Making this system that handles all the various different types of data, that's a little bit more complicated, but it can be done. Yes.
So I imagine not all of the data is directly tied to the GIS data you have. So for example, you have a GUI that just takes the location information where it is, but you don't have the location information you have tied with it. So how do you deal with those cases, or do you have like cases like that? Or not every data set has the GIS information with it.
Well, we handle the data sets that do have the GIS because, if you don't have the location information, it sort of creates a lot of barriers. You can't compare it to other data sets. You can't see where it is when all of this metadata. The more metadata that you have about this data, the more information you can gather out of this data. Because if it's just an array of numbers, then this is not really useful. Right?
So for most cases, like the GIS data included in the format as well, or do they come in like different file sets or something?
Yes. Pretty much any format you can think of.
All right, but I think we can have great conversations one-on-one. So both of us. Thank you.